Hello students, welcome to the next lecture on the topic analysis of the variance. Today we are talking about the new one, that is a two-way ANOVA, which is the extension of the one-way ANOVA. And in this presentation we will see the two-way ANOVA without the interaction factor. Okay, so we will see in the couple of slides that what is the meaning of the interaction and what is the meaning of the without interaction. So first of all, what is the two-way ANOVA? Two-way ANOVA is nothing but the extension of the one-way ANOVA by just considering the second factor into the analysis. If you remember, and I hope you have seen the last two videos on the one-way ANOVA. If you haven't seen that, I just request you to please go through the one-way ANOVA carefully so that you may able to understand the two-way ANOVA. A very easy manner and very fruitful manners are there. So what we have discussed in that, in the one-way ANOVA, there is only one factor which play a crucial role while during the analysis of any experiment. And here in this two-way ANOVA, we have considered the second factor also along with the first factor. So I just firstly recall the few terms which I have associated with these factors and levels are there. So what is the meaning of the factor? So as discussed, that factor is nothing but the characteristics of the experiment which are under the considerations are there, and the values in this factor is called as the level. Okay, for example, consider a group of the people which is divided into the two groups, that is first one is the experimental and second is the control group. And among these two groups, each people do some task, and for those peoples which are belonging to the control group, that is control group second, is given aptitude test having eaten a full breakfast, while which are experimental group students, they have give the same task but without eating any breakfast. Okay, so what is the meaning of it? That is the two people, the group of the peoples which are divided into the two groups. One group have take the test with the breakfast, one is without the breakfast. So what are the factor? What is the main part inside in this example? That is the factor is the meal. Okay, and what are the types of the meal? Either they have taken the breakfast or not. So these are the values of these meals. So that's why this called as the labels. I call as a two because there are the two values. So here look at that, there is only one factor associated with it. Okay, so since it is a one factor, so we call as this as a one-way ANOVA. On the other hand, if I just consider one more example, look at that, this as compared to the previous one, if I just selecting the group of peoples, group of peoples have 20 men and the 20 women are there, and they do the same task as in the example one. So how many factors are there? One is a gender, that is either a male or female, and second is a male. Now since there are the two factors, okay, so that's why we call as this as a two-way ANOVA. And similarly, if we have the three factors are there, we call as a three-way ANOVA. And what are the levels are there? How many genders are there? There is a two. So it means there are the two levels, men and women. How many meals are there in the experiment one? That is either breakfast or no breakfast. Okay. So how many observations we have recorded in that two-way ANOVA? So I can represent this information in terms of this table. This is my factor one, gender. This is my factor two, that is a male. Okay. Gender has a men and women. This is without and with and without are there. And this dotted line represents that the information about their peoples. That is the information about the test or analysis of the men having without breakfast. So they have some first person, second person, third person, so on. Okay, it may have a single, it may have more than one are there. Similarly, a person which have men and with breakfast, they have their recorded information out there. Okay, so it means in the first example we have considered that there are the one factor, and in this example we have considered two factors are there. So what we conclude is that one way or the two way just refer to the number of the independent variable. This is the most crucial things. In the look at that, there here the two factors, one is a gender and second is a male. So there are the two variables, and variables must be of the which kind is independent sign. Okay, so if there are two independent variables, we call as the two way. If there is the one independent variable, we call as the one way. So one way ANOVA has the one independent variable. It may have more than two or three groups are there. Like for example, in the previous case, one meal, that is a one factor, but there are the two, that is a with meal or without breakfast. Okay, so there are the two groups are there. Groups also called as the label. So let's say one more example is there. So consider an experimental design of the teaching method to evaluate the strength of the teaching to the students. Okay, so what is that? Up to this line, how many factors you have seen? This is the strength, this is not the factor. Okay, so experimental design on the teaching method. So there is only one factor which are associated with measurement of this. So there is only one factor, that is called as the teaching method. And what are the levels? How you teach them? Either on the online mode, okay, or on the offline mode, or the video lecture based. So there are the three groups are there. Since there is only one factor, so we call as the one-way ANOVA. So if I just want to convert this example itself into the two-way ANOVA, it means I have to add another factor into it, and that factor must be the independent of their teaching method. Okay, so if I use this strategy, then strategy definitely depending upon the teaching method, so they are not independent. So what we do is I have to add the new factor, that is called as the intelligence. So in the two-way there are the two independent variables. So one is the previous one. I have to add the intelligence are there. And since the teaching method have the three levels, online, offline, and the video, and here the intelligence I have considered again the three levels. You can also consider the two. You can also consider four levels are there. You can define them: high, average, low. If you want to consider the four, then you can call as a moderate, okay, very high, and so on. So it means this is now is a it's a two-way ANOVA. And how you define them? Here are my teaching methods, and here are my intelligence are there. And here is my high, this is average, this is low, and teaching methods are this is my online, this is my offline, this is my video based. And number of the observations are recorded in this 3x3 matrix. Okay, look at one more example. An agriculture experiment was conducted to compare the yields of the three varieties of the rice applied by the two types of the varieties. So is it one way or two way? What is the meaning of it? Is that this means there is a one is rice, and how many varieties are there? There are the three varieties of rice, which has been applied to the two types of the fertilizer. So since fertilizer P and fertilizer Q are the two types, and rice, and both are the independent to each other. These are the independent variables P. So this is called as the two-way ANOVA. So I hope you may be able to understand how to trace the one-way or the two-way ANOVA. That is totally based on the factors. So what are those assumptions which I have used in the two-way ANOVA, as we have considered in the one-way itself, but now this presentation on the two-way ANOVA. There are basically three assumptions, and the first one is which is only one observed measurement. It means if I have the two factors, that is factor 1, factor 2, say I call as a P and Q here, A, B, C, P, Q, R, and so on. So here, what is that? There is only one observation. It means P to A, there is only one observation. Okay, it can't be like this way. This means Q to A, there are more than one. This is not be there. So there is only one observed measurement. And the first one is the population is always be a normal distribution. Variances are same. This is same as that of the one-way ANOVA. What we have do is there is a third one. This is a new one we have added. The effect of the one factor here, if I say this is my rice and this is my fertilizer, okay, look at the previous example. So the effect of the one factor is same at all the levels of the other factors. Look at this at a level. It means the effect of the fertilizer A is same as that of the on A, B, and C. It means there is no interaction between the two factors. So this is the meaning of the interaction. That what is the meaning of interaction? I just explain in the next slide. Interaction means when the interaction exists, when the effect of one factor depends upon the level of the other factor. So effect of the one depends on the level of the other. How? Look at that. Consider the sugar having the levels either a none or the 2 teaspoon are there, and the second factor are there, that is the stirring. So here look at that, these are the two factors, so it is a two-way. Okay, and the stirrings again the levels are either none or the 1 minutes are there. So you have to consider the effect of the two factors, that is sugar and stirring, onto the sweetness of the cup of tea. Okay, so everybody knows that the stirring has the no effect on the sweetness if sugar is not added. Okay, it's quite obvious that, but it definitely have some effect if sugar is added. It means once you added a sugar of either the 1 teaspoon of the half or 2 or 3, then definitely a factor is happens on the sweetness of the tea. Similarly, adding the sugar has a little effect on the sweetness unless T is strict. Okay, so it means the sugar, that is the factor sugar and stirring, are said to be interact, that is they are dependent on each other. So it means this is a factor. Now in this presentation, what is, I just give you a remark about the interaction. When you analyze that whether your two-way ANOVA has interaction or not. First of all, interaction can only be assessed if more than one measurement is taken at each combination. What is the meaning is, look at this example. I just considered previous example, teaching method and intelligence. Look at that, how many values are there? It has more than one. Okay, it has more than one. So whenever there are more than one observation in a particular cell, this is my cell number 1,1, this is cell number 2,1. If in any cell it has more than one observation, we call as the interaction, always be. Okay, and in this case this interaction is there. And in this presentation we have considered the without interaction. So I just recall the definition of the ANOVA. It is an extension of the one-way ANOVA, one factor, and the level of this factor are determined by the grouping of the subjects. Here subject is also called as the labels are there, and each factor is defined as a blocking factor. Look at this. If I say this is A, B, and look at, if you look at the previous, these are my blocking. So this is my block 1, teaching factor, methods, intelligence are there. So these are my blocks are there. So that's why this is also called as the randomized block design. It is also called as the RBD. If you remember that in the one-way ANOVA, what we call as the CRD. C is for the completely, C is called as completely, R is called as the randomized, okay, and D is for the design. So that's why we call as the one-way ANOVA is also called as the CRD. While the two-way ANOVA, since it is the factor depending upon the blocks, block this is my block 1, this is my block 2, okay, so that's why we call as the RBD. So in this presentation we are talking about the one-way only for the two-way ANOVA without the interaction. Without the interaction means only one observation per cell we have noted out. So how you remember that when we use the two-way ANOVA or one-way ANOVA in your presentation or in your problem solving? So look at that. Two-way ANOVA is applicable only when the number of the observation in each of the subclasses are equal. What is the meaning is, that is when the number of the observation in each row are equal and the number of the observation in each columns are equal. Okay, then only you can apply the two-way ANOVA. For example, look at that. First of all, how many factors we have seen in this example 1? There is only one factor, ABC. There is no factor here. So it means this is a one-way ANOVA. Definitely a one-way ANOVA. Okay, look at here. There are the factor 1 and the factor 2. So it means it can be a two-way or it cannot be a two-way. Okay. So the second thing you have to measure that how many elements in the row 1, that is 4. How many elements in the row 2, that is 3. Since both are not equal, so it can never be a two-way ANOVA. It can never be a two-way ANOVA when the number of the observation in each row are not same. Look at this example 2. Number of the observation in the group in the row 1 is 4. Number of observation in the each row are 4. Okay, and also the number of observation in each columns are 3 and all are equal. Okay, number of the observations in each row are equal. In this particular example there is 4 and same number of the observation in each columns are also equal. It means here is a two-way ANOVA. So this is the example of the two-way ANOVA. This is the example of the one-way ANOVA. Okay, so I just recall that if in each cell, in each row, number of the observations are same. Here there is a 4, 3 and 5. They are not same, so it can never be a two-way ANOVA. It is always be a one-way ANOVA. For example, in here I just skip them. Okay, what is that? The number of observation, the first row is 4, second is 4, while third is not be a 4. So then again it is always be a one-way ANOVA, whether there are two factors are there or not. Okay, so then how you define the null and alternative hypothesis? So how many factors are there? There are the two factors. Okay, in the two-way ANOVA, so there is a need of the two hypotheses are there. That is H0 and H0 for the factor 2. So look at that, my row are there. So these are my row, these are my columns. That is factor 1, factor 2. So H0 is, here look at that, these are my rows A, B, C, D and so on. And these are my columns are, say this is my P, Q, R, S and so on. So what is H0 is, there is no difference between them. So it means we call as mu1 is equal to mu2 is equal to mu3. If there are the 3 rows are there. Or you can say, if there are more than, you can say mu I is equal to mu. And H1 is, there is a significant difference between them. Okay. Similarly for the column wise, if I say there are the 4, so you can say mu P is equal to mu Q is equal to mu R and mu S. And here they are not P. Or you can say this is again mu, say J, I have used here. So mu J is equal to mu, and here mu J is not equal to mu. So that is, there is a no significant difference between the mean of the column factor. If here columns are my rise, say for example, then I call as the mean of the rise. Okay. If there is a teaching method, we call as mean of the teaching factor. Then what is the source table be? How you design them? So this is the source table. Look at that, in the one way ANOVA we have always be a between the groups. Okay, here groups are the row and the column. So I just discretize into the two part. Rest all are similar. That is the between and the total. Here R is, now look at that. Our design is like, say this is my row column. This is my row. Okay. So how many factors are there in the row? How many labels are there? So this and this are my columns. Okay. So how you define the degree of freedom between the row? How many rows are there? So look at that. This is say up to the R and this is say up to the C. Okay. So R minus 1, where R is the number of the rows, C is my number of the columns. And since we remember that in the last slides we have seen that in the two-way ANOVA the number of the observation in each row is same. That is, what is meaning of that? If I say there are my A, B, C and D are there, here P, Q and R. So how many elements are there in the first row? 4. Definitely in the second is 4, third is 4. So how many observations are there? 12. So how you find that? Number of 3 multiplied by 4. Because in the two-way ANOVA, all the elements have, all the rows have the same number of observations. Or you can see no element is missing in the cell. So our task is to compute this. Our task is to compute this one, all those elements in this. So how you compute them? So look at one by one. Firstly, I just discussed this, this and this. Again, these values are quite similar. This means this SS divided by, as we have seen in the one-way ANOVA, this divided by this. So first of all, how you calculate the degree of freedom? Okay, so look at that. I just again, so here are my rows 1, 2, 3 and so on. Here are my columns. So what is the degree of freedom between the rows is, how many rows are there? -1. Similarly, number of columns, here total is how many observations are there inside it? -1. So this is the. Now how you compute the sum of the squares for the two-way ANOVA? We know that how to compute the SS, that is for the one-way ANOVA. We have already seen in the last 2 videos. So how you compute them? Firstly, we calculate the C, that is G square by N. Okay. Then we have calculated the SS total by using double summation Xij square minus C. And then we have calculated the SS between the groups in the one-way ANOVA is Ti square divided by Ni minus. This is the procedure for the one-way ANOVA. So we have extended the same to the two-way ANOVA. What will happen is that here how many groups are there? 2. Okay, so I just extended to be here. Look at that, there is my column, this is my row. Okay, so what will happen is, firstly you have to calculate the G square by N. How you calculate? So this is there. Okay, so what is that? Firstly you have to calculate total of this, called as a T1, second is T2, here is the T3, that is the total of. So how many elements are there in this? Is 4. Again here are 4, here again there are 4. Okay, and sum of the column wise we call as a again Tj here for the, and similarly for this total are there. and this is my G. You can see that whether either you can sum this or on this side, both have to be same G. So firstly we have to calculate the correction term C, then sum of the rows B, SS between the rows. So what is the sum is T1. T1 square, number of elements are here is 4. So T1 square divided by 4 plus T2 square divided by 4, T3 square divided by 4 and so on. So in journal it will be Ti square, I represent for the row, minus C. Same procedure for the column wise. So look at that. For this column, this is my sum of the Tj, number of the elements here is 3, so divided by 3 and so on, and total is remains same, that is square of this quantity, square of this quantity, minus of C, and error you can easily calculate 3 total minus of this. How you compute the MSS? Okay, so what is the meaning is you have find the this number, this is R minus 1. Okay, if I say this is my between the columns, this is my between the row between the columns, this is my within the error, okay, and this is my total B. This is corresponding to my this observation row column B. So there are C columns are there, so say there are the R rows, so this is this. How many observations are there total? How many elements are there? Since there are the R rows, there are the R columns, C columns, so number of the observations are total in there RC, because no elements is missing B. So this is RC minus 1B. Okay, and how you find this number is, that is RC minus 1 total minus of this number B, this plus this. Okay, so you can solve, you can find this number. Now second is SS, that is this is SS of the row, SS of the column, SS of the error, and this is SS of the total. This is we have seen here, SS row, SS total, SS column total, and this is called as SS error. Now how you find this MSS? That is nothing but SSR divided by this number, degree of freedom of the row, that is R minus 1. Similarly SS column divided by degree of freedom of the column B, C minus 1. SS error, degree of freedom of the this number. Okay, so look at that, this. So MSSR, that is mean sum of square of the R between the rows, is SSR, degree of freedom of the row. So I can say also as SSR, degree of freedom is R minus 1. Similarly for this, similarly for this. Okay, now how you compute the F ratio B? So look at that. Once you compute this, so in the one way ANOVA we have always computed a 1 F ratio because there is only one factor B. Now here there are the two factors. Okay, so how you compute them? So here we have calculated this is between the row, okay, this is between the column, this is error, and this is my total. Okay, and this is my MSS. So I call as this is MSS of the R row, MSS of the column, MSS of the error. So F ratio B. First F ratio corresponding to the row wise, that is MSSR divided by error B. Remember, always be error in the divided sign B. Similarly for the second factor, MSS column divided by MSS of the error. So this is the way to compute the F ratio between the row, between the columns. Once you get this value, then how you interpret them? Finally, whether you have decided to reject or accept the H0, this is based on this as usual. Since there are the two factors, one is the row wise, second is the column wise. Okay, so we have to draw the two normal curves, and this value is computed based on the degree of freedom. Okay, and then we have to check whether the value of the F is lies here or here, then decided whether H0 is accepted or rejected. So this is the procedure of finding the two-way ANOVA. So I just explained this procedure with a numerical example. So consider that a farmer apply the 3 types of the fertilizers on the 4 separate plots. So look at that, there are the 2 factors. One is the fertilizers, second is the plot. So it means there are the two factors. So it is a two-way ANOVA provided each observation, each row observation and the column observations remain the same. And the figures on the yields per acres are tabulated here. So first of all, check whether this is a two-way or not way. So first of all, there are the two factors. Nitrogen this is a one factor, and similarly this is the second factor. So it's a two-way. Two factors are there. Okay, factors are two. That's fine. And you have to check whether the observations in the each row and the columns are same or not. Number of the observation in the first row is 4, 4, 4. Column are 3, 3, 3, and it means row wise number of observations are same, column wise number of the observations are same. Here this is 4 each, this is 3 each. What we'll do is, so it means this is a two-way ANOVA, and our task is to check whether there is any significant difference between the fertility, this, or there is any difference between their plots are there. So what we'll do is, this is a two-way ANOVA, so what's our task is to compute this table. Look at that, this is the between the row. Here I just represent row as my fertilizers, okay, and these are my plots. So columns are my plots, errors and total. So first of all, what is the degree of freedom? So how many fertilizers or how many row are there in this table? There are the 3. Okay, so if there are the 3 rows, so degree of freedoms are my 3 minus 1, that is 2. How many columns are there? In this is 4. Okay, so that is 4 minus 1, 3. So look at the, what is that? There are the 3 fertilizers and 4 plots are there. What is the total? Always remember, this error line is always computed at the last point. What is the total? How many observations are there? You can see in the previous slide also, but since this is a two-way ANOVA, so it means no element is missing. Okay, so what is the maximum number of elements in it is 3 cross 4, that is a 12. You can also see that how many elements are there, 4, 4, 4. Okay, that is 12 minus 1, 11. Clear? So based on this, you can find the degree of freedom of the 11 is 2 plus 3 plus this is equal to 11. So it will be my 6. Okay, students, I hope you are able to understand how to calculate the degree of freedom as similar to the one-way ANOVA. Okay, so I just recall that how many rows are there in this example is 3. So degree of freedom is 3 minus 1. How many columns are there? 4. Degree of freedom is 4 minus 1. What is the total number of observation in here is, since it's a two-way, so no element is missing. So it's my 3 into 4, 12 minus 1, 11. So the sum is there. Now the task is to compute the SS. So how you compute this? Firstly, you find the null hypothesis. Since there are the two factors, so we define the H0. That is, since there are the 3 fertilizers, so mu1, mu2, mu3, that is the 3 fertilizers are equal effect. H0 for the second factor, there are the 4 plots, A, B, C, D, we call as. And what is H1 for here is, for the fertilizer is, there is a significant difference between the 3 fertilizer. This is my H1 for this factor 1, that is row wise. This is my for the row, and similarly this is for my column. So what is my H1 for the column B? There is a significant difference between the plots. So we have to check whether this assumption or hypothesis is true or not. So look at that. This is my initial observation. So how you compute the SS is, so firstly calculate the sum of this. 6 plus 4 plus 8 plus 6 is my 24, then 28, then 32. And similarly for the column wise, that is 6 plus 7 plus 8 is 21, this plus this is 15, this plus this 24, this plus this 24. So you can see that where either you can sum on this side or on through this side B must contain the same number. If there is a difference between them, you have to check your calculation. It means something is wrong in it. So what is the rule is that firstly you calculate the S, G square by N. What is the G is? This is my G. Okay, this is G is called as the, what is the G in my is G is called as my grand total. So what is that? G is my 84 square. What is N is how many elements are there? Total is 12. So 84 square by 12 is 588. Now calculate the SS between the rows. So row is my this. So what is the first row sum is 24. So formula is this. 24 square how many elements in this 24 is 4. So 24 square by 4 plus second part is 28. Number of elements in this 28 is again 4. 28 square by 4 plus 32 square divided by again 4 minus c. C is my 588, or you can write 84 square by 12. So after calculation you will get 8. Apply the same procedure for the column wise, that is a plot. So the sum is 21. 21 square, number of the observation in the 21 is this, that is only 3. So 21 square by 3 plus second is 15. 15 square divided by, again the observations are 3. 24 square divided by 3. 24 square divided by 3 minus of c. You will get 18. And the last is SS total. Total means this square, that is 64 square. Okay, that is 64 square. Oh, sorry, 6 square. First number, then 4 square, then 8 square, then 6 square, then 7 plus 6 and so on up to 10 square plus 9 square minus c always. So it will be 36. Okay, so based on this observation we can draw the final table as this. So look at that, this is the observation we computed in the previous slide, 3 6 2 3 6 11. So look at SS total. Look at that, SS total is my 36. So I just put up here as 36. SS between the row, what is the SS between the row is 8. SS between the column is 18. So I just put up here 8 and 18. Fine. So what is the value of it is? So you can compute them. So you can compute them here. This number is my, how to calculate this is 36 minus of this minus this. Okay, means this plus this is equal to 36. So what is that? This number is my 10. So this is my 10. Now calculate the MSS. So how you calculate this MSS is SS this divided by this, that is 8 by 2 is nothing but 4. Okay, 18 by 3 6, 10 by 6 that is 5 by 3. So I call as 1.666 and loss. Always remember up to the 4 decimal places. Okay, how you calculate this is my 18 by 3, this is my 10 by 6. Now how you calculate the F ratio is, so how you calculate that, that is 4 divided by error. Always remember error. So 1.667. Okay, and similarly for the second factor, that is 6 divided by 1.667. So what is that? The answer of this becomes 2.395, and look at for their third, this number is 3.593. Okay, so this is a way to complete the two-way ANOVA table. Now finally, what's the interpretation is? So what is the degree of freedom for this? You need f of 4. What is the degree of freedom of 4? 4 is my here. What is the degree of freedom? 4 is 2, comma, what is the degree of freedom of 1.667? Here is my 1.667, degree of freedom is my 6. So here is my 2,6. Look for the second one. What is the degree of freedom of this is? Here the numerator is 6. So where is 6 is? Here. What is the degree of freedom of 6 is? 3 divided by degree of freedom of 1.66 is 6. So you need the two values, f of 2,6 and 3,6 at 5% level of significance. So what are those values is this one. Okay, so there are the two-way ANOVA. So we have to use the two curves. One for the row, that is this is my row wise, and this is for the plot is my column wise. So look at this, 5.14 lies, this value is my 5.14, this value, and this value is my f for the plots. Plot is my column, and for the column we need the f3,6. So f3,6 is my 4.76. Okay, now you have to check whether your H0 is accepted, and this is the portion corresponding to the rejected H node. This is the portion corresponding to the rejected H node at 5%. So what is the value for the row? 2.395. So where it lies, that for the row 2.3 lies here something, while for the second one 3.5 for the column, 3.5 again lies here. it means in this case H0 is accepted. Okay, so it means your H0 is accepted. So what is H0 is? That is all are same. Okay, so what is the interpretation is, so for the fertilizer, since this value is less than, so H0 is not rejected, because what is that, look at that here, H0 is accepted. So H0 is accepted, or you can say you fail to reject the H0. So it means, it doesn't mean that, look at that, what is the H0 for here is all the fertilizers have the same, or what is H1 is fertilizer doesn't have their same impact. So it doesn't mean that the H0 is not rejected, means we conclude that data does not provide enough evidence to accept that the different fertilizers have different evidences. Similarly for the plots, again it lies on here, so we don't have enough evidence to show that. For here, what is that, here mu j is mu j, and here is this. Okay, so we can't say that that all the fertilizers have the same impact, okay, or all the plots have their same impact, or same fertilizer are there. So since this is accepted, it means we doesn't have the enough evidence to prove that. Okay, so I hope you may able to understand this one two-way ANOVA, their interpretations, how to solve them. Okay, so in the next lecture we will try to move more on this two-way ANOVA and try to explain or solve more examples, and say discuss some critical cases also. So best of luck students, be practice one way and two way more and more questions, so that you may able to understand their computational steps. Thank you, feel free to ask at any doubts.